To determine the appropriate size of a junction box, you must calculate the total cubic inch requirement based on the conductors entering the box. In this case, we have 3 number 1 THHN conductors and 3 number 4 TW conductors. Firstly, identify the number and size of conductors. We have 3 number 1 THHN and 3 number 4 TW conductors. Secondly, consult the National Electrical Code, NEC, Table 314.16, to find the fill space required for each conductor size and type. According to NEC Table 314.16, A. The fill space for a number 1 THHN conductor is 2 cubic inches, and the fill space for a number 4 TW conductor is 5 cubic inches. Thirdly, calculate the total fill space occupied by all conductors. For the 3 number 1 THHN conductors, the calculation is 3 conductors multiplied by 2 cubic inches per conductor, which equals 6 cubic inches. For the 3 number 4 TW conductors, the calculation is 3 conductors multiplied by 5 cubic inches per conductor, which equals 15 cubic inches. Adding these two values together, 6 cubic inches plus 15 cubic inches gives a total conductor fill space of 21 cubic inches. Fourthly, account for additional space needed for splicing and connections within the junction box. The NEC requires adding 25% to the total conductor fill space for splicing. This is calculated by multiplying the total fill space, 21 cubic inches, by 1.25, which results in 26.25 cubic inches. Fifthly, you should determine the minimum cubic inch capacity required for the junction box. The calculation of 26.25 cubic inches represents the minimum volume the junction box must have to comply with the NEC. Now, you can select a junction box that meets or exceeds this requirement, considering any space limitations. In this scenario, the width is limited to 5 inches due to spatial constraints. With a 5-inch width limitation, you need to find a junction box that has sufficient depth and height to provide at least 26.25 cubic inches of volume. As an example, consider a 5-inch by 5-inch by 5-inch junction box. To calculate the volume of this box, multiply the length by the width by the height, which is 5 inches times 5 inches times 5 inches, resulting in 125 cubic inches. This 5-inch by 5-inch by 5-inch junction box, with a volume of 125 cubic inches, would be suitable because it exceeds the required 26.25 cubic inches. It's important to remember that the NEC provides specific guidelines for conductor fill-in junction boxes to prevent overheating and ensure safe operation of electrical systems. Always consult the latest version of the NEC and local codes for accurate and up-to-date information. When selecting a junction box, it is always best to choose one that offers more than the minimum required cubic inch capacity. This provides additional space for future modifications or additions to the wiring system and helps prevent overcrowding, which can lead to overheating and potential safety hazards. If your calculation leads to a non-standard junction box size, it's often practical to round up to the next available standard size. This ensures you have ample space while still adhering to safety and code requirements. Consider the material of the junction box. Metal boxes are often used for exposed locations or where greater mechanical protection is needed, while non-metallic boxes are suitable for concealed locations. Ensure the junction box is listed and labeled by a recognized testing laboratory, like Underwriters Laboratories, AL, to verify it meets safety standards. When installing the junction box, ensure it is securely mounted and properly grounded. Use appropriate fittings and connectors to maintain the integrity of the wiring system and prevent moisture or contaminants from entering the box. Always to energize the circuit before working on any electrical components. Use appropriate personal protective equipment, PPE, such as gloves and safety glasses, to protect yourself from electrical hazards. If you are not comfortable working with electricity, consult a qualified electrician to perform the installation. Remember, this explanation is for informational purposes and should not be considered a substitute for professional advice. Always consult with a licensed electrician or electrical engineer for specific applications and installations. Failure to comply with the NEC and local codes can result in fines, safety hazards, and potential liability. Always prioritize safety and follow best practices when working with electrical systems. Keep in mind that the cubic inch capacity of a junction box is typically marked on the inside of the box or on a label attached to the box. Refer to this marking when selecting a junction box to ensure it meets the calculated requirement. If the junction box contains devices such as switches, receptacles, or terminals, additional space allowances must be considered according to NEC Article 314.16. The volume occupied by these devices must be added to the total conductor fill space requirement to determine the minimum size of the junction box. In situations where multiple cables or conduits enter the junction box, each cable or conduit must be individually calculated for conductor fill. The cumulative fill space of all cables and conduits must be considered when determining the minimum size of the junction box. When directing conductors for ampacity, due to the number of conductors in a raceway or cable, ensure that the junction box is adequately sized to dissipate heat. Overcrowded junction boxes can impede heat dissipation, potentially leading to conductor overheating and insulation breakdown. Always use appropriate wire connectors and splicing techniques within the junction box. Ensure that all connections are tight and secure to prevent loose connections, which can cause arcing and overheating. Follow manufacturer instructions for wire connectors and splicing tools to ensure proper installation. When running conductors through knockouts in the junction box, use appropriate bushings or connectors to protect the conductors from abrasion or damage. Sharp edges on knockouts can damage conductor insulation, leading to short circuits or ground faults. Consider using cable clamps or strain relief connectors at the point where cables enter the junction box. This will prevent tension on the conductors inside the box and reduce the risk of damage to connections. When selecting a junction box for outdoor use, ensure that it is rated for the environment. Outdoor junction boxes should be weatherproof or rain-tight to prevent moisture from entering the box and causing corrosion or electrical hazards. Always inspect junction boxes regularly for signs of damage, corrosion, or water intrusion. Replace damaged or deteriorated junction boxes promptly to maintain the integrity of the electrical system. When adding or modifying wiring in an existing junction box, always reevaluate the cubic inch capacity to ensure that it is still adequate for the new configuration. Adding conductors or devices to an undersized junction box can create a safety hazard. Consider using a larger junction box if necessary to accommodate the additional wiring. Ensure that all unused openings in the junction box are closed with appropriate plugs or covers. This will prevent dust, moisture, or insects from entering the box and causing contamination or damage to the wiring. When installing a junction box in a suspended ceiling, ensure that it is properly supported by the ceiling grid or structure. Do not rely on the suspended ceiling tiles to support the weight of the junction box and its contents. Consider using a junction box with built-in mounting brackets or clips for easy installation in a suspended ceiling. When installing a junction box in a wall or partition, ensure that it is securely fastened to the framing. Use appropriate screws or nails to attach the junction box to the studs or joists. Avoid over-tightening the screws or nails, as this can damage the junction box. When working with metal junction boxes, ensure that all metal components are properly bonded to ground. This will provide a low impedance path for fault current and reduce the risk of electric shock. Use appropriate grounding connectors or lugs to bond the metal components together. When working with non-metallic junction boxes, ensure that all grounding conductors are properly connected to the grounding terminal within the box. Use appropriate wire connectors or terminals to make the grounding connections. When installing a junction box near flammable materials, ensure that it is rated for the application. Use a fire-rated junction box to prevent the spread of fire in the event of an electrical fault. Always consult with a qualified fire protection engineer or authority having jurisdiction for guidance on selecting appropriate fire-rated electrical components. When installing a junction box in a hazardous location such as a chemical plant or refinery, ensure that it is rated for the specific hazardous environment. Use explosion-proof junction boxes and fittings to contain any potential explosions caused by electrical faults. Always consult with a qualified hazardous location specialist or AHA for guidance on selecting appropriate explosion-proof electrical components. Remember that the information provided here is for general guidance only. Always consult with a qualified electrician or electrical engineer for specific applications and installations. Adhering to NEC regulations and local codes is crucial for ensuring the safety and reliability of electrical systems.